When you're working in a team, the ability to give and receive feedback is probably the most important thing, even above technical skill. So this video is all about how to conduct a design review. If you're working in a team, it's probably prudent to conduct design reviews on each other's circuits to make sure that there's good alignment of the features, that everyone agrees on the features, inputs and outputs, etc. And also that you're all sticking to team standards, because when you're working in a team, the stakes are so much higher. You can't hold as many things in your mind. And so you have to create these little functional bricks that all connect together in an agreed upon way. So this video is all about design review. Now, a design review can take the form of a checklist. This is where the designer and an independent peer reviewer sit down together and they just go through the checklist together and do their due diligence. So I'm looking at the current evolution of the new teams, or at least the new racing DDR checklist. And this has a lot of things about compliance with various milestones, even with folder structure. Time spent getting organized is never time wasted. There are tabs for PCB design intent, for short answer questions. And as I click through this document and we get into more of the review stage where we start asking questions, this is a pretty intimidating document. There's a lot of items here, which is a disadvantage because it feels like a big job to go through. But the advantage of this is that it assumes zero knowledge. So someone who is making their very first circuit can use this essentially as the style guide. They can work backwards as a style guide from this. Normally you would have the designer and at least one reviewer for this process. I don't have the designer with me, so I won't be able to ask them the questions. This will be kind of an open loop review. But in any case, I'm going to assume that all of this compliance is met, that the directory structure is compliant, the design intent is well documented and agreed upon, and we're going to skip straight to the review items. And I love that the first thing is the ERC. I'm going to assume the ERC runs on this with no errors because I have installed KiCad on this machine and may not have things set up correctly. So the ERC is probably going to be a nightmare. I love that the next thing is the title block, all the metadata, designer's name, relevant team name present. Yes. We have board name. Yes. We have revision number. Yes. Great. This is just a checklist. We have neatness and quality of life. This can be a hill to die on. A neat schematic is so much easier to read though. So yes, it's valuable to keep it neat. Distinct circuits are in blocks. They're labeled, beautiful. It's very clear that these engineers have taken a lot of pride in laying out this schematic. And it really shows. It's very organized. And look, we're not going to dwell on this checklist too much more because you kind of get the picture, right? These items are self-explanatory, and so they should be. What I really wanted to talk about with this video is kind of the softer side of the design review process, and that's the ability to give and receive feedback well. If you're the reviewer and you open a schematic and you're like, this sucks, that's a terrible place to start. It's not very constructive. Remember, this is somebody's art that you're looking at, so act like it. Approach it with a sense of curiosity and ask good questions. So what I like to do, let's assume the checklist is done. Everything is compliant. I don't necessarily think we're done yet. Your value as the reviewer is not to just go through the checklist, but to just cruise around and have a look at things and just look for unusual signals. Things that make you go, that's interesting, or things that you don't understand. There's a great opportunity here for a transfer of knowledge. If there's something you haven't seen before, then you might learn something, and your design partner might learn something as well. So just cruise around the schematic. It looks like we're using a lot of very standard blocks, which is really cool. I can see that there are last updated tags on each block, which is interesting, rather than having a complete revision every time a change is made. That's cool. One pattern that I do notice a lot are these reused input patterns. So I'll just have a look at those because I can see this guy, and it's a pretty unusual value of resistor. And so this is probably an agreed upon standard type of symbol or a standard type of input schematic, but I might just say, hey, why is this 19.5? That's kind of an unusual value. And then you look a little bit deeper and you go, oh, okay, well, there's a 10 and there's about 20 here. So this is a divide. This is a 2/3 voltage divider. This is probably dividing 5 volts down to 3.3 volts. And by the value of that resistor, it's probably bang on 3.3 to like a very close tolerance. And so the question that I would ask is it necessary to use this kind of exotic value? Could you get away with 20K? What might that look like? If there was 20K here, then you would have a 1/3 voltage divider. And so this 5 volts would divide to a little over 3 volts. And so, you know, that's very easy to justify having that exact value. But is it necessary? Is it necessary because we have this Zener voltage clamp, this Zener diode clamp here? So this could be a 20K. This could be, I don't actually know if 20K is standard, but I know for sure that 22K is like, it's one of those values that is available in every series probably. And so yes, this voltage could now be more than 3.3, but doesn't matter. It's just a question. It's not, I'm not saying that this is better. It's just a question of, is it necessary to use this part? And why am I even asking this question about, you know, it's a resistor? Because the whole point is to reduce risk. So for every specialty part that you use, the risk increases. And in this case, it's just a resistor. You buy a reel of 1,000, 10,000, and the problem's solved forever, right? But the risk increases just a tiny bit. For every one of these things, the risk goes up just a little bit. Maybe there is no risk because we have thousands of these parts. And so great, no change. Don't do anything. But is it necessary? And so then the question can be extended. Is it necessary to use a unique value here? Maybe it might be, just a question, maybe it would be better to consolidate parts and instead just use the same value. And this is now just a matter of philosophy, right? Now we've converted that 22 or 20K resistor into two 10Ks. Do you prefer to have fewer parts or fewer unique parts? It's just a question. Is it necessary? Because we can make the same thing. We trade off using that kind of exotic value of resistor for two that we're already using everywhere anyway. The next question might be, is it necessary to have it at all? Could we use the internal pull down resistor here and just allow the Zener diode to clamp this net? Because it'll do that. You'll have, if this is 5 volts and this is 3.3 volts, you've got about 2 volts, about 10K. So that's about 0.2 milliamps flowing through this diode. This may work just fine. There may be a very good reason for keeping this here, so you don't have to use the internal pull down on the input. I don't know. All I can do is ask the question because I don't have the full context of the design. The designer does, but in asking that question, hey, maybe we've saved using a unique part, or maybe we've saved using an entire part. But at the end of the day, you know, ask yourself, does it even matter? This is extremely robust. If this Zener diode fails, this voltage divider still works. For example, if it wasn't soldered properly. So this is still extremely robust because you'll still get 3.3 volts. And you betcha the microcontroller here has internal Zener diodes to protect itself. They're just not as beefy as these ones. That was a long time to spend splitting hairs about a resistor, but this is how you might approach this kind of perusal of the schematic, to just ask questions. Does it increase or decrease risk? And sometimes the answer isn't clear because there are no solutions, there are only trade-offs. But remain curious for stuff like that. Oh yeah, this looks like we're doing a 12 to 3.3 volt signal. Oh yeah, that's in the title there, very useful. I can't tell you exactly what we're looking for here. We're just looking for things that are unusual or set off alarm bells. I've never seen this before. I don't know what this is, so I'm going to jump over to the PCB. And yeah, I guess this ground pad on the back here was just required for some reason. Maybe that's part of the enclosure and there's a grounding connection for, I don't know, shielding or something. I don't know anything about that, so I would probably be like, hey, what's this about? But otherwise, you know, I'm sure it's probably fine. 500 ohm resistor, yeah, that looks like a good resistor for 5 volts. 1K is a pretty good resistor for 12 volts. We've got some standard reverse polarity protection. This looks like we're reusing some standard team schematics, which is great because we are relying on the lessons that have already been learned, so we can focus on like the new lessons to learn, I suppose. So that's a bit of enough of like perusal of the schematic. You get the vibe, right? We're just looking for things that that are just notable. We've done the checklist, and now we're just getting vibes. Just getting vibes from the schematic. Just seeing what speaks to us. Pretty much the same thing for the PCB, honestly. I like to start with the render. The render's great. So much context built into the render. You can see our engineers have been so diligent. This is really, really nicely compacted, really nicely compressed. For what is a very complicated looking circuit, they've done a very good job. We can see a lot of the condensing of the resistors onto the footprint of the teensy, which is quite inventive. It also means that all these signals are kept pretty short because this is exactly where they're needed. So yeah, this looks like a lot of care has been put into it. The routing looks pretty sensible. The trace widths look pretty reasonable. That's just the signal, I presume. Yeah, I'm really just looking, again, for things that appear unusual. And the better something is laid out, the easier that is to do, because you're basically just looking for breaks in patterns. I love that these test points are so nicely labeled. I guess, one thing that might be a little tricky is that these test points are hidden between the connector and the microcontroller. That might just be a little tricky for quality of life to actually get probes in there, but it seems like it's going to be a thing that's one and done. So maybe we're just probing in with a multimeter, because I think these are probably all like DC set points, right? We're not going to be getting in there with the parrot clip of an oscilloscope probe. So it's probably fine. I mean, of course, we can get at them from the bottom if we really need to. We may never actually solder in these test points. It may just be probes only. Of course, the checklist would want us to run, probably to run the ERC or the DRC first. If I were to run it, we just have warnings, which is great. Warnings, missing footprints, that's probably my fault as I was setting this project up. Princess Muscles reference, love it. It's always nice to put a bit of yourself into your circuit boards. And one thing that I can see is, I wonder if this was auto routing. Maybe, but our designers have been very diligent for their routing to have horizontal on the front and vertical on the back, which is an old trick, right? If you do horizontal on the front and vertical on the back, you're going to have a shitload of wires, but your routing is going to be hopefully pretty straightforward. There are trade-offs. It's a very simple way to approach routing, but it can make things very, very straightforward. Keep your life easy. That's cool. Nice work. And so for this I actually have no real questions. I have no observations. This is great. We've passed the DRC. I don't know what the rules are set up for, but that the clearance looks great. It looks very, yeah, we're using default clearance, which is super conservative enough for commodity PCB manufacturers. We have nothing but the default net class, super conservative enough. We're not dealing with high power. I would really just seek to get an alignment on what this is for and what this means. That's about it. Is it to clip something onto? Maybe it's just to clip. It's to clip the alligator clip of an oscilloscope onto, isn't it? Yeah, it's right at the edge of the board. There's no routing on the other side. Yeah, I reckon that's what that is. That's neat. I like that. It doesn't look like we have any risk because there's no routing up here. There is routing here, so if you slip off the back of the pad, assuming it even is for this, but if you slip off the back of the pad, you could like wear away at the mask and it's fine. It's going to be fine. That's a cool feature. Yeah, I like that. All right, that's gone on enough. I think you get the point. Checklists are very powerful. They are super powerful. The one that we have is very long, but that's for a very good reason. The ability to give and receive feedback. Stay curious. You are talking to someone about their art, and it would not surprise me if the designers who worked on this had spent well into the double-digit hours on this project. So keep that in mind. When you're asking your questions and when you're receiving your feedback, be respectful and you just want to reduce risk. That's all we want to do. And there are so many reasons to lose sleep at night when one person's idea of reducing risk is different to someone else's. And so if you're drilling down and it gets that deep, like, these resistors, like, God, why would I even bother commenting or changing these resistors? We got heaps of them. Those are the kind of things where you can get stuck in a circular conversation or argument about something like this. If you find that's the case, it's just so not the point. It is sometimes unfortunate that different people will disagree on what reduces risk. And that's because there are no solutions. There are only trade-offs. Let's be good to each other.